Hello again. We'll kickstart this series of tutorials off by first establishing what displacement mapping is. In a nutshell, displacement mapping is the process of moving or displacing the vertices of a 3D mesh based on the information stored in a 2D image. This is demonstrated on our shield in the Lesson 2 Marmoset toolbag file provided, and will be the object that we'll be working on throughout this displacement mapping portion of these tutorials. Now we'll go into more detail about how exactly displacement mapping works in the next lesson. But the first thing we should discuss is the fact that in order for displacement mapping to be truly useful and effective, it must be coupled with a separate process known as tessellation. To understand why, let's think about the displacement mapping process. What we're essentially doing is moving the vertices of a mesh to form more detail, or in some cases to form an almost completely different mesh. So logically, it must follow that our final displaced mesh has the same number of vertices as our original. Unless we're doing some form of animation or transformation using the displacement, this isn't very useful. Because if we just want to be able to see the final product, if we don't want to at any point see the original mesh, then the whole displacement mapping process is completely pointless. Why, if they already possess the same number of vertices, wouldn't we simply have the final product from the start? This is where tessellation comes in. What tessellation allows us to do is subdivide a mesh, creating more vertices which can later be displaced. Let's use our shield as an example. If we pop to the render tab in the top left corner and turn on our wireframe, we'll see that the shield has a lot of vertices. But if we go over to the tessellation widget here and turn the tessellation level down to 0, we can see the original number of vertices, and that in this case there aren't very many. Also, because of the lack of vertices, our displacement mapping is suffering greatly. We haven't got any of the little knobs sticking out. We've got a sharp point instead of a nicely rounded bulge. There's just no real detail to speak of. But if we turn up the tessellation, we'll see more and more vertices formed, and all the detail will slowly pop in. So now we've established why displacement mapping is reliant on tessellation. But we haven't talked about why all this is necessary. Why would we want to go through the process of tessellating a low poly mesh and then displacing it? Why would we not just have the final product? Now, we're only going to talk about this in the context of games. We're not going to talk about movies or anything of that kind of nature. In games, there are two main benefits of using these processes. The first is in loading times. If we picture a level or a map within a game, and we take out all the original models and replace them with lower poly versions, which will then get tessellated and displaced, and by the end look exactly like the originals had. By doing this, we will have taken out thousands, possibly millions of vertices from the loading stage of that level, and effectively decreased its loading time. We will, however, have to additionally load in the 2D images, which will then go on to displace our meshes, but the trade-off is ultimately beneficial. The second benefit is in storage space. All games must store their models on the computer or console that the game is installed on. Models that have a greater number of vertices take up more storage space, and so by replacing them with models that possess fewer vertices, we save space. Again, requiring the 2D images does work against this, but once more, the trade-off is worth it. It should be pointed out at this stage that tessellation is a very computationally heavy process for real-time engines such as games, and that current computer hardware has not developed to the stage where tessellation can be used on anything and for everything. In addition, development into more optimized forms of tessellation, known as adaptive tessellation, could result in it being a more viable option for games in the near future. So in this lesson, we have outlined what displacement mapping is, why it is reliant on tessellation, and some of the benefits and drawbacks of the use of these processes in games. In the next lesson, we're going to expand on our understanding of displacement mapping.